Thank you, Dr. McCalla, for setting the stage. Dr. Price.
Thank you. Not to be difficult, I want to talk about the micro-level efforts in food security, particularly technical innovation and its role in assuring food security. You may recall, some of you, that the Green Revolution was ignited by, in fact, the technical innovation that drove even macro policy for a period of time as administrators and bureaucrats scrambled to find a way to best facilitate the new technology that had been developed for the wheat and rices that have made such a difference in preventing famine and creating food security for a period of time. Of course, we know that the problem of food security remains with us because of issues of poverty that would enable people to purchase the grains that were provided. Food security should include an emphasis on technology development and technological innovation. What are the prospects for technical change in Latin America? I wanted to talk about a number of the partnerships between national programs and international agricultural research centers and collaborators elsewhere in the world and the kinds of innovations that those are bringing forward at this time that show some promise for advances in food production. The International Potato Center in Peru deals with high-yielding, disease-resistant potatoes. We know that worldwide this is beginning to make an impact, particularly with the disease-resistant varieties that have not only improved the yield but are also finding niches in markets and in production areas that were susceptible to high disease. The International Center for Tropical Agriculture is dealing with a large number of commodities, but is most recently talking more and more animated about the cassava varieties that they're working with that have a high propensity for adaptation to different climatic regimes as prospective climate change takes place. Cassava is adapted to tropical regimes, to high rainfall, as well as extended periods of dry conditions. So the cassava is a plant that has a lot of promise for improved calorie production. The International Maize and Wheat Improvement Center has a number of innovations that are very important to us presently. The collaborators worldwide continue to work on wheat yields, but are most concerned presently about wheat diseases, particularly the stem rust that has new strains of stem rust that are moving from Africa into the Western Hemisphere and threaten the wheat production in the region worldwide. The work on improvement of wheat disease resistance is being supported presently by the Gates Foundation, and other collaborators are entering into this as well. Another of the CIMMYT efforts in collaboration with colleagues is with quality protein maize. This is a variety of maize that is high in amino acids that are more digestible by humans and animals. It's not that it's higher in protein absolutely, but higher in the kinds of proteins that can be digested more rapidly. And this is very important for both humans and animals. And finally, they're working extensively in conservation agriculture. It was mentioned earlier that not only do we need to have improved tillage methods, but possibly no tillage methods, that is, methods that conserve the soil. In fact, the current thinking in conservation agriculture is to introduce and test methods that have limited disturbance of the soil, continuous crop cover in terms of cover crops, leguminous plants, and others, and crop rotations. Those are regarded as the three fundamental precepts of conservation agriculture. There are many questions as to whether or not that particular technology can produce the same amounts of food that the higher technology, that the advanced varieties, high fertility rates, and high uses of tillage practices. In fact, now there's a tremendous effort going on to look at the labor requirements of these conservation agriculture systems. And of course, IICA is playing a role in working with these technologies to make sure that they're cataloged, kept, and disseminated widely through the technical leadership and knowledge management. Another series of collaborative efforts with Latin America are those conducted by U.S. universities and partners in the collaborative research support programs. There are many advances that have come through that. Most noteworthy recently, we're looking at higher yielding peanuts, disease resistance, and associated with that, technologies to reduce aflatoxins in the feed and human supply system. White sorghum for human consumption is another product of the collaborative research in sorghum millets with Latin America. White sorghum is a preferred grain in El Salvador, for example, and the varieties have been developed to the point now that they can be milled to bread and be used as a replacement for wheat in those economies that can better produce sorghum rather than wheat, sorghum being adapted to dry conditions. Land rights and governance are much a part of the collaboration between U.S. universities and Latin American countries, as well as improved dairy products and dairy nutrition. Earlier, I was really excited when Ambassador Johnson spoke of the importance of grain legumes and high-protein forages for the tropics. He's hit the nail right on the head. Not only the high-protein forages required, but neither have scientists made a breakthrough in high-protein grain legumes. That is, soybeans are primarily adapted to temperate regimes, and we've never been able to get tropical soybeans to achieve the same yields as are possible in temperate regimes. So much more science is needed there. And finally, disease-resistant animal breeds. One of my colleagues at Texas A&M proposed in a symposium not too long ago, he said, if I could produce a GMO cow that produced milk that prevented malaria, would you let me do it? This is the kind of thing, and this is actually, he is so firmly convinced that this is within the realm of possibility within a few years that he's extremely disappointed that, or I won't say disappointed, he's trying to find investors who will go with that kind of research. It would be a wonderful advancement. I won't talk too much about the impediments to the adoption. We know that all of these increases would require a complementary effort in macroeconomic policy and in extension and education and so on. I only wanted to mention one feature, comparative disadvantage in staple foods. Many of the governments of Latin America have let their staple food production remain largely at the subsistence level because at the trade, it has been possible to trade for staple foods in wheat, maize, and so on. Particularly under NAFTA, there's been a specialization in many Latin American countries to produce horticultural crops, and other regimes are producing the staple crops of cereals. But recently, during the food crisis, these same governments, and I will say it was not limited to Latin America, but especially in other parts of the world, discovered that when the prices went up, they were not able to find the stocks of grain that they'd hoped to import. And when they looked into their reservoir of technology for producing locally, it wasn't there. They had not kept up their reservoir of technology for domestic production. So even if it's not possible or it doesn't seem reasonable to produce wheat, maize, or other staple crops in the country currently because of comparative disadvantage, it's still nevertheless worth the effort of national scientists to stay in collaboration with international scientists and keep a reservoir of technology on tap for those days and those times, and it could be an entire era, when it becomes possible again